Hello folks, we come to the part 8 of the exercise 9.3 and let's continue with the remaining problems. In the previous video we couldn't complete the 22nd problem to some technical problems, so let's complete that and then come to the 23rd problem. We were at this a raised to q minus r till this step and then we will continue from there. We were opening the bracket and we are taking the next term. Also, we can take b raised to r minus p, which is b for us is a r raised to q minus 1 multiplied by r raised to r minus p, that comes to a raised to r minus p into r times, we open this bracket up, actually this into this. So, qr minus qp minus r plus p, and then you have the last term c raised to p minus q, which comes as a r raised to r minus 1 whole raised to p minus q, so that comes to a raised to p minus q into r raised to rp minus rq minus p plus q. We can just have it opening up like this. Okay, since we want the product, let's consider the product. Therefore, a raised to q minus r into b raised to r minus p into c raised to p minus q, net effect works up as a raised to q minus r into right away we can do one thing. A raised to m minus n is a raised to m by a raised to n, we know it like that. So, either that we could write it like that, or we could have it like a raised to q into a raised to minus r, and this is r raised to pq, r raised to minus pr, r raised to minus q, r raised to r. The next term, it is a raised to r, a raised to minus p, r raised to qr, r raised to minus qp, r raised to minus r, r raised to p. Then a raised to p, a raised to minus q, r raised to rp into r raised to minus rq, r raised to minus p, r raised to q. So, let's see now how this will be clubbing up together. You know that if you could club a raised to q and a raised to minus q together, how would the powers go? A raised to q minus q, a raised to 0. So, like that, when we have all the powers clubbed up together, it will be a raised to q, and I could have written it like that, right? A into q minus r plus, I think this step is unnecessary. Now, we shouldn't have done this. We could have written it directly. I think that's right. Yeah, we'll do one thing. We'll write this as a raised to q minus r into r raised to pq minus pr minus q plus r. Then we have a raised to r minus p into r raised to qr minus qp minus r plus p. Then we have a raised to p minus q, r raised to rp minus rq minus p plus q. You know that a raised to m into a raised to n is a raised to m plus n. The powers will get added up. By that idea, all these three powers will get added up. And so also these are having the same basis, so the powers will get added up. Okay, and see what happens in the powers, they are all cancelling each other. PQ with PQ, PR with PR, RQ with RQ, minus P with plus P, minus Q with plus Q, R with R. So, what we get is a raised to 0 into r raised to 0. Anything raised to 0 is 1. So, net effect the answer is 1, and that is what they have asked us to show. So, you can say hence proved. So, that's how you go about doing that problem. That was your 22nd problem. Now, we can come to the 23rd problem, where they are telling us that there is a GP where the first term is called as A and the nth term is called as B. If that is the case, when you take the product of those n terms, you should be able to show this. That is what they say. So, let's start right away that let A comma R be as usual in a GP. So, given that an is b, which means it's a r raised to n minus 1, which is becoming b. So, r raised to n minus 1 is b by a. I don't know whether we'll require, but we'll keep it like that. So, product they are asking. Also, the product, what would it be? First will be A, then will be AR, then will be AR squared, then will be AR cube. Yeah, first term, second term, third term, fourth term. Last term AN is AR raised to n minus 1. That's how you have first term, second term, third term, and all that. Last term, we are taking the product. We are writing it like this. So, what will happen? How many A's are there? 1, 2, 3, 4. So many A's. A into A into A into A, like that. N A's, we are putting them together. N times. Then we have R into R squared into R cube and so on, R raised to n minus 1. A raised to m into A raised to n is A raised to m plus n. Bases are same, you can add up the powers. So here also, A into A, like that, n times it's getting multiplied. So it will become A raised to n. Here what will happen? We know that the powers will get added up. 1 plus 2 plus 3 and so on, n minus 1. Now by now we have already studied in our binomial theorem that 1 plus 2 plus 3 and so on till n, if it is there, then it is like writing n into n plus 1 by 2. But because here it's only n minus 1, it will become r raised to n and n minus 1 by 2. I hope you can see the change. When it is still n and n plus 1. When it's still n minus 1 and n. Okay, so we have the term like this. But in the question they ask us p squared. So let's consider square. Therefore, p squared is a raised to n into r raised to n into n minus 1 by 2 whole squared. The power applies to both. So a raised to 2n into r raised to n into n minus 1 by 2 into 2. The 2 can get cut. So what are we left with? A raised to 2n into r raised to n into n minus 1. Also, let's consider what is ab raised to n. ab raised to n for us, a, and b for us is this. A r raised to n minus 1. So let's check what happens. A squared r raised to n minus 1 whole raised to n. So this applies. A raised to 2n and r raised to n into n minus 1. It's applying. So we have both these becoming equal. Therefore, p squared equal to ab whole raised to n is proved. Yes, that's about doing this problem. Now we come to the 24th problem where they say that you have to take the sum of first 10 terms in the GP. Then you have to take the sum of terms after the nth term, that means n plus 1 term and so on, and take the ratio. You have to show that the ratio is 1 by r raised to n. Let's do it. Let a comma r represent as usual. So you have, consider a1 plus so on an and an plus 1 so on a to n. By formula, first a, then ar squared, and last term ar raised to n minus 1. So ar raised to n plus 1, last term ar raised to n minus 1. Now in the numerator, what is common? A. So you can have the a out. 1 plus r squared, r raised to n minus 1. In the denominator, but it's not like that, a r raised to n can be common. Why? Because this is a r raised to n into r. Next term will be a r raised to n into r raised to 2 and so on. This will be a r raised to n into r raised to n minus 1 if you want. Yes. So you can have throughout a r raised to n taken out common. So you have 1, here only 1 r is left, here only 1 r squared is left, and last term there is r raised to n minus 1 which is left. What is the advantage? Cut. What are we left with? That's what they have asked us to show. Yeah? Hence proved. Right. And then quickly we take the 25th problem, which I have written it down. They say that A, B, C and D, these are 4 terms in a GP, and for this they give us a relation and they ask us to show whether this relation is okay or not. That is a question. So they give us that A, B, C and D are in a GP. So let A comma R be as usual in a GP. So what does it mean? B is the second term, so it's AR. C is a third term, so it's AR squared. D is a fourth term, so it is AR cube. Right. First term, second term, third term, fourth term. This is how we write it. Then you have to show this. Why don't we take the left hand side, do it, take the right hand side, do it, and show that they are equal. Yeah. So consider A squared plus B squared plus C squared times B squared plus C squared plus D squared. Let's see what it is. A squared is A squared. B squared is A squared R squared. C squared is A squared R raised to 4. Then again B squared is A squared R squared. C squared is A squared R raised to 4. Then D squared is A squared R raised to 6. Have the A squared common. So it is 1 plus R squared plus R raised to 4. Have the A squared R squared common. So what we have 1 here. See, this is A squared R squared into R squared. So R squared left. Then this is A squared R squared into R raised to 4. R raised to 4. Right. So if you could bring all the terms together, you could probably have A raised to 4 into R squared into 1 plus R squared plus R raised to 4 the whole square when we club the terms together. Alright, let's look at this also. AB plus BC plus CD the whole square. Let's check what comes. A will stay as it is. This is AR. B is AR. C is AR squared. D is C is AR squared and this is AR cube. So let's check all this. This is A squared R, A squared R cube, A squared R raised to 5. So squares are there, okay. So take A squared R common. We'll be left with 1 plus R squared plus R raised to 4 whole square. Right. And this can apply. So A squared R whole squared and 1 plus R squared R raised to 4 whole squared. So that's A, again apply. A raised to 4 R squared 1 plus R squared R raised to 4 whole squared. Thus, what's that? A squared plus B squared plus C squared into B squared plus C squared plus D squared is equal to AB plus BC plus CD the whole squared is proved. If you would have taken LHS and RHS, we could have written therefore LHS is equal to RHS, hence proved. So that's about this, and this is our problem number 25. We'll finish this video with this problem, and with more problems are coming in the next video. Thank you.